Section 2. Deploying Container Platform Portal. In this section, we will learn about how to build Container Platform Portal and how to utilize the core functions by accessing to the portal. Part 1. Portal Installation. The picture shown in the textbook is the main page of Container Platform Portal, and it is the most used service for building container platforms. Next, we'll use the GitHub installation guide to understand the process of installing the portal service. You can find the guide documentation on the GitHub page. Follow the link shown at the textbook. Before we proceed to installation, let's look at the system diagram of the container platform. The system configuration of the container platform consists of Kubernetes cluster environment and a storage server for data management. The Kubernetes cluster environment installed through KubeSpray, middleware environments such as Harbor, which manages the container platform portal image, and Helm chart, Keycloak, which manages container platform portal user authentication, Vault, which manages authentication data, and MariaDB, which manages metadata, are provided as containers. To deploy the container platform portal, you need to create a path and download the deployment file. This step must be done on the Kubernetes master node. First, create a path to download the deployment file inside a workspace folder. Create a folder with the name of container-platform. Download the deployment file to that folder and verify the file path. Once the download is complete, unzip the deployment file. The deployment files directory is organized as shown in the textbook screen. The scripts folder contains variables and script files related to deploying the container platform portal. Images folder contains portal image files. Charts folder contains the portal's Helm chart files. Values.org folder contains the portal's Helm charts values YAM files. The Keycloak.org folder contains files related to deploying Keycloak to manage user authentication for the portal. Next, we'll describe the procedure for defining portal variables. Before you deploy the container platform portal, you need to define the values of the variables. For this, you need to set the variables by checking the information required for your deployment. Here, the default deployment method for Keycloak is HTTP, and if you want to set up HTTPS with a certificate, you need to refer to the Keycloak TLS setup guide in the orange box and complete it first. Let's go back to the procedure for defining portal variables. Enter the following path: Workspace Container Platform CP Portal Deployment Scripts. Run the CP Portal PaaS shell file. Proceed to the screen where you can edit shell file. Enter the Kubernetes master node IP, host cluster as type, and provider type as shown in the textbook. The textbook describes a standalone deployment, so for the provider type, enter standalone, which means a standalone deployment. In this part, we'll show you how to run the container platform portal deployment script and verify that the portal-related resources have been successfully deployed. First, run the script to deploy the portal. Once the deployment is complete, verify that the portal-related resources are deployed successfully. Use the kubectl getAll command to check the normal deployment of each resource. In the case of pods, it may take a few seconds for them to bind to the node, create the container, and go into a running state. Let's take a look at the resource search screens for each open source. First, the Harbor resource lookup screen. Harbor functions to manage portal images and Helm charts in a Kubernetes cluster environment installed through KubeSpray. If you type kubectl getAll-n Harbor, you will see the same screen as in the textbook. At this point, make sure that the deployment status is all running. Next, the MariaDB resource lookup screen. The function of MariaDB is to manage metadata, the data we use to describe other data. If you enter the kubectl getAll-mariad command, you will see the same screen as in the textbook. At this point, make sure the deployment status comes up as running. The Keycloak resource lookup screen. Keycloak is responsible for managing user authentication for the container platform portal. If you enter the kubectl getAll-Keycloak command, you will see the same screen as in the textbook. Similarly, make sure the deployment status is running. This completes the resource lookup. If you want to delete a deployed container platform portal resource in the future, run the script with the commands below. First, retrieve the deployed resource. Then use the commands in the textbook to delete resources. Be careful not to delete while the container platform portal is running, because all resources required for operation will be deleted. After entering the command, enter Y to confirm the deletion. You can then confirm that the resources are deleted. Part 2. Cluster Installation Demonstration. Watch the video for the installation process we've been through so far. Part 3. Portal Access. Part 3 shows how to access the portal you built. The container platform portal can be accessed at the address in the textbook. Enter the Kubernetes master node public IP value in the braces, and the master node IP value in the textbook. You should see the initial screen of the portal, as shown in the image in the textbook. There are two main types of portal accounts: administrator and user, and we will learn how to log into each type of account. First, logging into the administrator's account. You can check the initial information of the administrator account through the commands in the textbook. After checking that information, you can log in by entering your ID and password on the portal's initial screen. Next is logging into the user's account. The user must sign in first. Click the Register button at the main page of the portal. Then input the required information, then click Register to complete user registration. User cannot log into the portal immediately after registration. The administrator must assign namespace and role for the user before the user can access the portal. For more information on assigning namespaces and roles, see GitHub Container Platform User and Operator Portal User Guide. Once namespace and authority has been assigned from the administrator, log into the Container Platform portal. Part 4. Portal Utilization. In Part 4, we'll take a look at how to utilize the portals you deploy in Container Platform. First, let's see the three main types of Container Platform portal user authority. The super admin account, which is a global administrator, has full cluster management authority. Next, the cluster admin account, which is a cluster administrator, has administrative authority only for the cluster to which it is assigned. Finally, the user account, which is a regular user, has administrative authority only for the namespace within the cluster to which it is assigned. Familiarizing yourself with these authority types can help you get more out of your portal. Next is the Container Platform portal menus, which are categorized into global, cluster, workload, and service. Storage, config map, admin, info. There are 8 main menus. Here's a brief description of what each menu does and how to use it. The Global menu. From the subpage of Global menu, click Overview to view cluster information and the top nodes, CPU and memory. Immediately at the top of the dashboard, you can see your clusters, namespaces, persistent volumes, persistent volume claims, and the number of pods. The Clusters page allows you to view a list of clusters, view details about each cluster, or create, register, and modify clusters. On the right side of the screen, you'll see the Create button where you can create and register a cluster. Let's learn the process of creating a cluster. When you create a cluster, you need to enter the following information. After entering all 6 fields, click the Save button to configure the cluster environment. Here's what you need to enter. First, cluster name. Enter the name of the cluster to create. Second, provider. Select the provider of the cluster to be created, such as AWS, OpenStack, etc. Third, cloud accounts. Select the account information for the selected provider. Fourth, template. Select the HCL template for your VM deployment. Fifth, description. Enter additional information if needed. Finally, template details. Enter your personalized environment information based on the selected HCL template. Next, let's look at the information you'll need to enter when registering a cluster after it's created. When registering a cluster, you'll need to enter the following. The cluster name and provider are the same as when you created the cluster. The cluster API URL is the Kubernetes API URL of the target cluster. And finally, the cluster service token is the authentication token for the cluster admin authority to access the target cluster. Once all of this information is entered, the cluster registration is complete. Next is the cloud account from the third sub-page of the global menu. On this page, you can see a list of your cloud accounts, view individual details, and create, edit, and delete cloud accounts. Here, the cloud accounts are used for the credentials needed for automated VM creation through IAC, and are stored securely through Vault software. However, the inputs vary depending on the provider. For example, let's compare AWS and OpenStack. AWS requires 3 inputs, while OpenStack requires 5 inputs. Always remember that depending on the provider, cloud accounts require different inputs. The Instance Code Templates page. An instance code template is a template of code that performs automated VM deployment through IAC. In this menu, you can create, view, modify, and delete these templates in advance. By pre-registering instance code templates, you can easily deploy subclusters through the K-PaaS container platform. The portal provides templates for AWS and OpenStack by default. Next, we'll describe the features of the second dashboard, clusters. First, the Cluster Overview dashboard allows you to view the number of namespaces, deployments, pods, and users, as well as charts of deployments, pods, and replica sets. When viewing, you can select a cluster name from the selection box at the top of the screen to view information about the selected cluster only. After selecting a cluster, you can select a namespace from the selection box to view information about that namespace. If you select All under namespaces, you can get information about the entire namespace. The Nodes page in the Clusters menu. This page allows you to view the full list of nodes and the details of each nodes. You can click a node name in the node list to go to the node details page. Next is the Namespace page, where you can view a list of namespaces, details about each namespaces, and create, modify, and delete. Click the name of the namespace you want to view in the list to go to the Namespace Details page. The third main menu, Workloads. Workloads include deployments, pods, and replica sets. The first is the Deployments page, where you can view a list of deployments, details about each deployments, and create, modify, and delete deployments. On the Pods page, you can view a list of your pods, details about each pods, and create, edit, and delete pods. Finally, the Replica Set page allows you to view a list of replica sets, details of individual, and create, edit, and delete. The fourth menu, Services, has 2 subpages: Service and Ingress. On the Services page, you can view a list of services, details about each services, and create, edit, and delete services. The Ingress page allows you to view the Ingress list and details of each, and create, modify, and delete ingresses. The fifth storage menu has 3 subpages: Persistent Volume Claim, and Storage Classes. The Persistent Volume page allows you to view, create, modify, and delete lists of persistent volumes, and details of each persistent volumes. You can also manage persistent volume claims and storage classes on the other 2 pages. This is how Persistent Volume Claims page looks like. This is how Storage Classes page looks like. 6. In the Config Maps menu, you can view, create, modify, and delete the config map list and the details of each configuration map. The Management menu can manage users, authorities, and resource quotas. First, on the Administrators tab of the User page, you can view, create, modify, and delete the list of cluster administrators and the details of each cluster administrators. At this point, you can grant 1 or more cluster administrator authorities. The Users tab on the right allows you to look up a list of general users, view details, create, modify, and delete information. If you click the Users tab, there are the active and disabled tabs. The Active tab refers to the list of users assigned a namespace and role within the cluster. The Inactive tab shows a list of users in that cluster who have unallocated namespaces and roles. You can go to the General User Details page by clicking on the user ID. On this detail page, you can click the Modify button to assign cluster administrator, or end user, authority to the user on the Modify page. If you set authority as a cluster administrator, select Cluster Admin in the authority entry. If you set up general user authority, you can select as a user. Click the Select button and select the namespace and role to assign to the user. The roles page allows you to look up, create, modify, and delete the list of authorities and the details of each authority. The Resource Quotas page can manage resource quotas as well. Refer to the Screen for Limit Ranges page. Lastly, Info menu is to view user information, environment, and usage settings information for using the CLI of the container platform. Private repository information can be checked. For detailed use guide of the portal utilization, please refer to the GitHub guide. This concludes Section 2 Deploying Container Platform Portal. In Section 3 we will learn about deploying Container Platform CI/CD pipeline. Good job everyone!